We humans love aliens, or rather I should say we love the story of aliens, the science, the fiction, the sci-fi, if you will. The notion of first contact is so intriguing because of the hundreds of questions such an event would instantly answer. The biggest one being, are we alone in the universe? Storytellers have long explored what such an event would look like, delighting readers and viewers with hypotheticals ranging from the scientifically possible to the complete fantasy. In many of these stories, aliens arrive with incredible new technology and answers to the universe's biggest mysteries, with the issue of communication just a short challenge that seems fairly easy to overcome. But if aliens did arrive, would communication really be that easy? Would they really have the answers, and would we even be able to understand them? And could a single equation capture all of these possibilities? Welcome to Ideas for Our Time.
We choose to go to the moon.
There are things we thought we knew and don't know.
And it's one of the things we're hoping to discover.
I have a dream today.
Today's idea comes from Daniel Whiteson.
Hi, I'm Daniel Whiteson. I'm a professor of physics at UC Irvine, and my main research is colliding protons at the Large Hadron Collider, trying to make new forms of matter to learn what the universe is made out of, fundamentally.
Do Aliens Speak Physics is a book by Daniel and cartoonist Andy Warner, exploring all the theoretical factors that you may not have considered and that we may not have properly addressed in stories about first contact.
Physicists have this fantasy that aliens will show up and 10 minutes later we're at the chalkboard and we're talking Lagrangians, we're doing 17-dimensional integrals, and that seems wonderful and like how exciting. Not only because we've been butting our heads up against these problems for a long time, but the idea that the answers are out there and somebody knows them and they could just give them to us. Aliens could have been doing science for millions or billions of years, literally, right? So the idea that we could leap forward, it's so tantalizing. But I'm a skeptic, and I worry about things I want to happen. In science, I'm very careful not to draw conclusions that I want to be true, because I know it's easy to fool yourself. And so the book is essentially an extended argument for why that might not happen and how it could go wrong.
You can find an excerpt of his book on our website by clicking the link down in the description. To tackle this problem, Daniel takes inspiration from the famous Drake equation. Originally formulated by astronomer Frank Drake in 1961, it's meant to estimate the number of communicative alien civilizations in the universe. It's a probabilistic estimation, calculated by breaking down that big question into individual factors that are multiplied together, like the number of stars in the universe, the fraction of those stars that have planets, the fraction of those planets that support life, and so on.
And there's some real genius in the Drake equation. There's a reason that it's persisted, not because it's got a complicated structure to it, right? It's not fancy like the Schrödinger equation or the Dirac equation. It's just a bunch of numbers multiplied together. But the structure of that equation has real insight. It tells you if any of those factors are zero, right? The number of planets around stars, the number of times life forms around planets. If any of those are zero or really, 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 really tiny, then it's hopeless because they're all just multiplied together, right? Any zeros and the whole thing is zero. So I took that as a way to structure our examination of this question of whether we could be at the chalkboard talking Lagrangians with aliens. And we started from the number of aliens we might be able to talk to, the number of aliens that exist out there in the universe. And then we asked, well, what fraction of those actually do science? And then what fraction of those could we even communicate with? And then what fraction of those do we have questions in common with? And finally, what fraction of those aliens who we do science and we can communicate with and are curious about the same stuff have answers that would fit in with ours? Answers that are not like on a completely separate stream or answers that we could understand. And so that's the way we broke it down, because it turns out there's lots of ways that this fantasy could go sideways.
Daniel calls this the extended Drake equation, the probability that humanity will be able to exchange scientific ideas with interstellar visitors. Today, we'll consider these four factors one by one and explore not only how they might help us prepare for possible alien interactions, but moreover, what they might tell us about ourselves and the way we view reality. Let's begin with F-science, the probability that alien civilizations do the kind of experiment-driven science that we do here on Earth to learn about the universe. Like many of the social terms in the original Drake equation, this seems impossible to calculate, You might think that, of course, any alien civilization that can make its way to Earth must have used science to reach the needed technological milestones. But Daniel uses examples from right here on Earth to show why that is not necessarily the case. Throughout your book, it's not always hypotheticals. You're showing that there are actually examples of all of these probabilities from our own human history and our own interaction with other cultures. And I think for this one, you discussed how actually we haven't even been doing science for very long. And we progressed a huge amount before we got to the point of actually asking questions about how things work rather than just showing that we can do things.
One of my motivations for writing this book is that I feel like there's an understanding in popular culture about what is science and how do we do it and what it means. And that understanding is kind of cartoonish. You know, that like we came up with science in one afternoon in the 1500s, and then we've been sciencing ever since, and that hasn't changed. And that basically everything we've discovered is because of science. But you're right, in human history, we've had technology for a lot longer than we've had science, right? People have known how to do stuff like making swords that are super duper sharp, right? And resistant to dinging. Without knowing the condensed matter physics involved. In many cases, we still don't understand why things work. Like nobody knows why Tylenol works, but we've known that, you know, you can extract this from a plant and do this and it cures headaches. So in many scenarios, we know how to do something without knowing why it works. And that tells you that it's possible to develop technology without having a deep understanding of the mechanisms. Obviously, science accelerates technology. Like our pace of technological development has been huge since we've been doing more experiments and developing mechanistic understanding, but it's not required. And so one of the scenarios we work out in the book is the idea that some species could, over millions and millions of years, sort of intuit their way into warp drive technology and show up here on Earth with the ability to move between the stars fairly rapidly. And then when we ask them, like, so how does quantum gravity work? They're just like, what do you mean? Here's how you build it. What else do you need to know?
Each factor in the extended Drake equation is essentially a probability, so must range between 0 and 1. Human history gives us some hints about the possible value of F signs, but at the moment we have no real way to estimate it. Let's see if we can do any better with the communication factor, the fraction of those scientific alien civilizations with which we can actually make contact. In many media depictions of aliens, communication is very easy. Often, the aliens already speak English, or learn to quickly. In other cases, alien language has essentially the same structure as human language, and powerful translation devices exist to ensure that communication difficulties don't slow down the plot.
Oh, that is a lot of fun. It's a universal translator.
In other movies, communication difficulties are part of the story. Maybe there's a code that needs to be cracked. Maybe the aliens communicate with musical tones instead of articulations, or with strange circular symbols that have no start or end. But even in these cases, the aliens still have so much in common with us that through determination and hard work, humanity prevails in establishing contact. But how realistic is that, really?
Yeah, I do think that they are operating under different constraints because they have to make the story fun. And a story where you get a message from space and you never figure it out is not a whole lot of fun. And I think that in reality, it's going to be a lot harder to crack that puzzle, especially if the aliens don't show up. You know, if the aliens send us a message, and one of my favorite depictions of alien contact is, of course, Contact by Sagan. I think it's a super fun book, lots of really cool ideas in there. But the scenario that he depicts where we get a message from aliens and without their help, we're able to crack the code and convert this series of blips into concepts, I think is almost impossible. And if you talk to philosophers of language, they're very, very skeptical that this could ever be done. And, you know, in human history, we found it very challenging to break even human codes. Right? Human codes where if you could translate it, you could recognize it as translated. Like when the Allies were working on the Enigma machine, if they figured out the code, boom, German pops out. So they know they figured it out, right? What's the analogy here? You get a message from aliens. You could be translating it all sorts of ways and have no idea when you've done it correctly because you can't recognize the output. And even in the example of human cultures, there's lots of failures, like lots of cases where human languages have never been translated, dead languages where nobody is around anymore to tell us what the answer is. And so, we have a few examples like hieroglyphics, but if you dig into those those are more cautionary tales than encouraging anecdotes.
Right, because it took the Rosetta Stone to solve, right, rather than just a lot of work and eventually cracking it.
And not just the Rosetta Stone. It took the Rosetta Stone, plus it took 20 years, right? They had an example where they had the answer 20 years. So in Contact, the aliens encode their message in exactly the way we would have encoded it and the way that we did encode it for the message that we sent. And that would be wonderful, and I hope that's true, and I love the book, but I think it's very, very improbable that the aliens would write to us essentially in English. It's like the mathematical encoding version of aliens have already been listening to our messages and write to us in English, which I would welcome, but I think it's too much to hope for.
So primes, 2, 3, 5, 7, those are all prime numbers, and there's no way that's a natural phenomenon.
Once again, human history provides examples of how communication with aliens may be far more difficult than media depictions suggest. If we can't even understand dead languages from our past, created by members of our own species, what hope do we have for decoding alien languages? That is, if aliens even have language.
Aliens might have completely separate ways to communicate, not even through sound or these kind of familiar senses. They may have evolved like some form of telepathy, right? There's no physical reason why we can't be telepathic, right? Like our brains can generate electromagnetic waves. They can sense electromagnetic waves. In the right evolutionary context, you could develop, biological telepathy where minds are connected more directly. And so the whole concept of translating your ideas into symbols, which then populate the ideas back in somebody else's head, could seem very strange to them.
So understanding aliens may be very difficult, but maybe we could speak to them. How would we go about creating a simple message to explain who we are and where we are in the universe? As it turns out, we actually did this already. In the 1970s, Pioneer 10 and Pioneer 11 were launched as the first human-built objects to achieve escape velocity out of our solar system. On each spacecraft was a plaque designed by Carl Sagan and Frank Drake, the same Drake who came up with the Drake equation, with illustrations by Linda Salzman depicting humanity, the 9 planets, galactic landmarks pointing to our sun, and this strange symbol that we'll come back to later.
But in the remote contingency that there are interstellar spacefaring societies which might someday pick up this derelict no longer radioing, we thought we would put a message on it to indicate a little bit of where we are, when we are, and who we are.
A few years later, they repeated this process for Voyager 1 and 2, which were launched with these golden records. On the cover of the records, many of the same illustrations appear, along with instructions on how to play the records to decode the contents, which include carefully selected images and sounds from humanity.
We wish to extend greetings and friendly wishes to all who may encounter this Voyager and receive this message.
Hello from the children of planet Earth.
It feels very optimistic. Even the Voyager discs feel extremely optimistic. I mean, firstly, that they have to figure out how to play a record and know that the sound waves are the message.
Mm-hmm.
And they've put together all of these codes and these steps along the way. But again, that might only make sense to humans. I mean, in the way that with hieroglyphics, that's only 2,000 years apart of members of the same species that we've not been able to decode. I was wondering if, I mean, given how much technology has even advanced since the discs were sent, if they looped back and landed on Earth in 1,000 years, if anyone would be able to decode what the disc said, you know?
That's a great question.
Like, would they even have a sense that it's something that you can play?
Yeah, right. Well, you know, I took the Pioneer plaque, which is not the Voyager record, but the original plaque, and it has this little depiction of hydrogen atoms on it and tries to define a unit of time. And but I took the images on the Pioneer plaque and I gave them to a bunch of grad students here at UC Irvine in physics. So these are like the ideal audience, right? Humans, like minds marinated in physics, so ready to interpret things as a human physicist might. And I gave them a few hours looking at these things and say, guess what these symbols mean. And they had no idea. Nobody came anywhere close to guessing, oh, this is the spin flip of a hydrogen atom and they're using it to define a unit of time. Like nowhere close to that. And so I think that it's just much harder to imagine, the context that's needed for an alien to guess this, right? If humans can't even get it, the chances for an alien seem very, very small. And, Sagan was trying to do something which I think is literally impossible, which is create a self-decoding message, a message with symbols which can be translated only back into one set of ideas and with a decoding that's described within the message, right? Philosophers of language say this is not possible because the symbols you use to communicate, these words I'm using to talk to you right now, or things we scratch on paper or whatever, these are arbitrary. We could choose any set of symbols. And the choices we've made are cultural. And it works because we agree on it. And we painstakingly teach our children what our choices were. But if you're not around, there's no context, there's no human to explain it to you, it may be literally impossible to decode. Props to Sagan if he's right. But I think it's probably harder than he imagined.
Yes, that symbol I mentioned before represents the spin-flip transition of a hydrogen atom, which has a period of about 0.7 nanoseconds. Light can travel about 21 centimeters in that time, so this illustration is designed to allow a single dash to represent either a unit of time or a unit of distance, which allows for larger times and larger distances to be represented using binary. Would you have figured that out if you had enough time? Would an alien species figure that out if they found the disk? I think it can be optimistic and also an almost impossible task at the same time.
Yeah, and worth trying, right?
We're still trying to figure out how to warn future human generations not to dig in places we've buried nuclear waste, right? And that's still a challenge.
Right.
How do you color the grass or something like that to make humans know that this means don't dig rather than dig here?
Exactly. What will that mean to a human in 40,000 years?
Nuclear semiotics is the field dedicated to warning future generations not to dig in places where we've buried nuclear waste, which will remain lethal for longer than we've even existed as a species. Language is generally seen as an unreliable tool for this. Even symbols are no good. It's estimated that less than 6% of the world's population recognizes the supposedly universal trefoil nuclear warning sign. Instead, people in this field suggest using hostile architecture or biologically engineered flora to scare people away in the future. If sending a message as simple as "don't dig" to our descendants remains an open problem, that might not be good news for the potential value of our communication factor. The next factor, F questions, represents the chance that scientific aliens that we communicate with are investigating the same questions that we are. The recent sci-fi blockbuster Project Hail Mary would have been a very boring movie if Ryland Grace first made contact with Rocky only to discover that Rocky was there to investigate something that we found boring or uninteresting. What do we even know about human curiosity in the first place? I was really interested throughout the book of this notion of curiosity, right? Is it a human thing? At the same time, is it something that is maybe innate to any life form that evolves? Maybe to get to the point where you are an intelligent species, you need to have been curious. Maybe curiosity is a necessary part of that evolution.
I mean, on the side of inevitability, it seems to make sense, right? It seems like intelligence and curiosity are deeply connected. And for example, we do have examples of other intelligent species. My dog is pretty intelligent, like he solves tricky problems, like what sounds mean Daniel's opening the fridge, or what words mean, we're about to go for a walk. These are not simple, like information processing problems, right? So we see curiosity also in those animals, right? Like my dog's definitely curious. Cats famously curious, right? So there are examples of intelligent creatures here on Earth that are also curious. So that suggests that curiosity is not limited to humans, at least, though, of course, these are all, mammals with similar backgrounds and similar evolutionary history and evolutionary context and all sorts of stuff. And yet we also see in humans a huge variety of curiosity and people being curious in some things that other people find boring. So that suggests that aliens might be curious, but they might be curious about very different things. But I think that this is the kind of thing that's impossible or very, very hard to think outside of our human box, to imagine the experience of what is it like to be an alien, what's important to them. We don't even understand human curiosity, right? Like where it comes from and why it's important and all this stuff.
Maybe we have a feeling that we are exploring all of the questions of the universe, that we have biologists and physicists and chemists, and we're tackling everything. But do you think it could equally be that, again, this is a very human-centric view, that we are focusing on questions that come naturally to us, but there could be an infinite number of questions that we don't even think of as interesting things to explore, that another species would have devoted their entire existence to?
Yeah, absolutely, I do. And this touches on a really fascinating issue in philosophy of science, which is essentially, why is the universe explainable or understandable at all? Because as you say, it feels like we're asking all of the questions. We're curious about everything. There's always somebody out there who wants to understand whatever it is you're interested in. But the universe is throwing a huge amount of information at us. It's overwhelming. The amount of data that comes in is really vast. And that's just a slice of representing what's out there. We know that most of the universe that's out there is not available for us to sense. We can't see ultraviolet photons, we can't see neutrinos, we can't see dark matter. There's a huge amount of the universe that we cannot sense. And yet, even within that slice that we do sense, there's too much for us to understand. And so we do this magic trick where we extract simplicity out of complexity. You can look at a ball flying across your backyard and you can summarize that in a simple mathematical equation. And the amazing magic trick that's happening there is ignoring all of the little details involved. Like, that ball is made out of 10 to the 29 little quantum particles. We don't understand quantum mechanics well enough to predict what happens to 10 to the 29 quantum particles. We can hardly do calculations with like 100. And yet, we don't have to. It all coalesces somehow magically into a simple mathematical structure that we can describe with a single equation. Why does that happen? Why does simplicity emerge from the universe? Nobody knows the answer to that question, which means that it might be a feature of the universe, right? That somehow things coalesce at various levels and there's mathematical descriptions of this without explanations. Or it could be that there's some humanity there, that we are drawing arbitrary dotted lines around things that are of interest to us and finding approximations that fit them well enough to satisfy our interests. Essentially, are we imposing human lenses on the universe? And you might think, well, that's silly. I mean, obviously, there's some things that just emerge, like planets, right? Planets orbit the sun, and surely alien Kepler figured out, their rules, and alien Newton figured out gravity and ... But, planets are a great example because they're something we're very interested in because we live on one, and we tend to overemphasize their importance. Like if you look at the Pioneer plaque, there's like a map to our solar system. And the map is not like representative. The planets are way out of scale on that map. And basically every representation of the solar system, the planets are like way zoomed up. So like we're super duper biased towards planets. The solar system is basically the sun plus a little bit of, debris, or maybe the sun and Jupiter and a couple of dust specks, right? But we focus on Earth and these little rocky planets because they're important to us.
Yeah, I mean, in the 50 years since that plaque was sent out, we changed our mind about whether Pluto was a planet, right? And so,
Exactly.
So maybe this ability of ours to find simplicity among the chaos of the universe is a human trait. Maybe aliens also find simplicity in the universe, but in a completely different way that would prevent us from ever doing experiments together. And it's not just our brains that might be imposing a biological bias on the questions that we ask. It could be our senses, too. I like how you dive into the senses a bit in terms of we'll have these questions based on what we perceive about the universe. And yes, we're getting a very limited sense, but what are the chances that other aliens have eyes, right? Mm-hmm. Have you seen or read Project Hail Mary?
Oh, yes, absolutely. And thoroughly enjoyed it, of course.
The whole conversation that they have about seeing versus hearing. And
Mm-hmm.
I think Rocky says something like, how amazing that humans can hear light, this thing that we need instruments to detect, and we might have a similar thing with another sense.
And I think that gets at something really fundamental. It's not just about what senses you have, because you can add senses, right? You can build new technological instruments that let you experience something of the universe. Like we can hear gravitational waves and we can detect that neutrinos are there and all this sorts of stuff. So we can escape our biological limits using technology, but it also shines a light on the importance of those initial biological senses because they define our experience. Right? Rocky is talking about hearing light, and he's describing it as hearing because he has no qualia, no experience of what it's like to see. Right? So he has to define it in terms of his intuitive experience. And this is an analogy for what we're doing in physics all the time, is that we are describing the unfamiliar in terms of the familiar. And then we're limited by our intuitive language, this dictionary of concepts that make sense to us, that we require everything to be translated into. And so it might be that aliens have a different set of senses initially, and even if we, in the end, explore the same universe technologically, they're translating their ideas back into their intuitive mental language, which makes sense to them, and we're doing it back into our language, which makes sense to us. But as we know, sometimes those ideas can't be perfectly translated, like quantum mechanics, right? Maybe there are aliens out there for whom quantum mechanics is intuitive because they have some weird sense that is quantum mechanical. And so for them, our questions about quantum mechanics just seem like they're coming from the wrong place. And their answers don't satisfy us, right? They don't give us that intuitive understanding because they can't translate that. Can a blind person ever understand what it feels like to see something? How could you translate that experience? It's a famous unsolved problem. So we may end up in that scenario where aliens are like, it works like this. And we're like, huh? I don't get it. Because there is a fundamental sort of subjective and personal sense at which something makes sense to you.
So alien questions might be completely different to ours, not only because of the nature of curiosity, but also because they might have a set of senses that completely alters their intuitive understanding of the universe. What does that tell us for the potential value of the questions factor? Once again, Daniel uses human history to give us a hint.
And I did a bunch of really fun history archival research to understand, how did different early societies approach the questions of science and math and astronomy? Were those different? Do those point in different directions that suggest that, even among humans, things could have gone very, very differently? So that, of course, aliens, who can imagine? So that was a lot of fun to dig into. And I discovered that, Chinese astronomers used very different kind of mathematics to describe the universe than the Greeks did or the Mayans did. And it suggested a different mental framework. They were algebraic and arithmetic instead of being geometric. And of course, 1,500 years later, we know that geometry and algebra are deeply connected. So of course they're probing the same thing, but it changes sort of their mental structure. So we don't know what would have happened if the Chinese had stayed independent or the Mayans hadn't been wiped out. What would Mayan science be like today? It's a fascinating thought question.
I think one of the optimistic outcomes of that thought experiment was that despite there being all of these independent cultures, they did still all feel curious about the same things, even if they were approaching them in the same way. So maybe that's a hopeful point for the questions question. The final factor, F answers, is where it starts to get really philosophical. This factor has the least to do with aliens, because even if all the other factors line up in the extended Drake equation, if there's aliens out there who do science and we successfully make contact and they have the same questions as us, it could be that the answers are not those we are looking for. This factor is about the very nature of reality, probability that there's an actual fundamental truth out there, and that all of our science hasn't been for nothing. How far do you think we are to finding a fundamental truth about the universe, given how short our pursuit has been? Or do you think we could be barely scratching the surface with everything?
We've never found anything which is fundamental. Everything we've ever discovered is made of something smaller. The idea that something could be fundamental, that it's made of itself, is an assumption based on no evidence. right? Sure, we haven't seen what the electron is made out of, but there's very strong hints that it must be made out of something smaller because there are all these emergent patterns in the periodic table of the fundamental particles which are not explained and which smell a lot like the emergent patterns in the periodic table of the elements, which were eventually explained by microscopic structure. So it could be that there is no fundamental explanation, that it's just like smaller bits of smaller bits of smaller bits all the way down an infinite tower of stuff with no firmament on which it rests. And that feels very uncomfortable because it conflicts with this comforting sense that there is a single explanation out there, some, Planck scale reality out of which everything else bubbles. But those are assumptions. And, the goal of putting this in the frame of the alien context is to ask, what assumptions could aliens make, right? Are they approaching this from another angle? And so it might be that there is no single true objective reality out there that we're probing, that it's this crazy, intense patchwork. And there are extreme philosophers out there like Nancy Cartwright who says that in the boundaries, maybe there are no laws. Maybe what happens by hap, which is very hard for me to have an intuitive understanding of, but also I have no evidence to disprove it.
Right. We get to that fuzzy place in philosophy where, is it Gödel's incompleteness theorem that there are truths that might be completely improvable, but that it could be that there's no objective truth to the universe, but it could also be that there is a truth, but it's impossible to ever find it.
Yeah.
And which must be very frustrating as a physicist.
Yes. Or it could be that there are multiple equally good theories about the universe. We have this sense that because our theory is precise, that therefore it must be unique. But that's another leap, right? We could have a theory of quantum fields and maybe we make it work and explain everything away. And in 1,000 years, we're very happy with our theory. And then the aliens arrive and they have a theory of quantum schmields. And it's totally different, and it tells a different story about what's happening in the universe. And it works just as well. And then we're like, well, what's real? Fields or schmields? Like, well, maybe no, both, maybe neither. What does that mean about reality, right? So we don't know that there's a single answer out there. It's an implicit assumption in most of our science. It underlies the whole scientific process. I'm not saying science is a religion or anything like that. I'm just saying we need to recognize that we go beyond just interpreting our data sometimes and making philosophical assumptions about what it means about the universe. And those assumptions are assumptions. And there's always a philosopher who will argue the other side of any of those assumptions.
Well, that's what we can rely on philosophers for.
Thank God for philosophers.
With a sample size of 1, we can't tell whether humanity is typical or anomalous in the universe. Even finding one other example of life in the universe would instantly convert this unique occurrence into a distribution, helping us answer questions about how common life is, how life forms, and how varied life can be. But if we found intelligent aliens, we could also learn something profound about the way that we view the universe.
We've been building this edifice to explain everything we see and everything we observe in all of our experiments for hundreds of years, and it works really, really well. But we don't know if that explanation is the only possible explanation. And that's something that always worried me, that maybe there's some humanity in our physics. The age-old question of, is this the map or is this the territory? Are we describing reality or is this just some mental shorthand that we're using? And I feel like in the way that, biologists wonder when aliens arrive, they'll learn about whether human biochemistry is unique and human intelligence is unique or common. We will learn about whether our explanations of the universe are unique or common or weird or what.
By now you may have realized that I never did give you estimates for the 4 factors in Daniel's extended Drake equation. And Daniel doesn't know them either. Just like the original Drake equation, this equation is not meant to be seriously used to calculate some true value or even a vague estimation. In the end, these equations are a thought experiment, which could end up telling us more about ourselves than they do about aliens. My understanding is that by the time you get to the end of the book, what you have achieved is really this same notion of curiosity, but for the reader. Mm-hmm. You've kind of used the framing of this hypothetical to really explore what it means to be human. You say something along the lines of, we should be our own aliens with this question. I was wondering what you meant by that.
Yeah, you're right. I don't give a number at the end. And in the same way that we don't have a number for the Drake equation, the point is just that many of the things that we might have, if we thought about it superficially, assumed were 100%, could be zero. But I don't want to give the impression the book is a downer, right? I think the book is arguing that it's more likely than not that there will be some obstacle to making this scientific connection. But even in that scenario, even if we aren't learning quantum gravity on day one, I also wanted to argue that we're learning something about ourselves. And so the question of like, what are the answers to the secrets of the universe is a fascinating one. But if we don't get those, we'll learn something about the human lens, right? We'll learn some perspective. The same way that when you go traveling and you taste breakfast in a new culture, you learn something about, your parochial tastes. Like you couldn't imagine that people had weird fish soup for breakfast or whatever, and now it blows your mind. And so in that way, when aliens come, whatever it is that goes wrong along that chain, we'll learn something about the choices we made, and it'll open up new doors. So I think it's a happy ending either way, unless, of course, the aliens just nuke us from orbit.
A good sci-fi story is not really about aliens or lasers or warp drives. A good sci-fi story uses a distance setting to explore deep questions about humanity. Daniel's book ends up being the same. Like any good sci-fi book, these hypotheticals teach us about ourselves by asking why we do what we do, why we are the way we are. By being our own aliens, we learn a bit more and we stay curious. Thank you for watching Ideas for Our Time.